Hello, in this video we will continuing a series on finding the range of function, but particularly here we'll be dealing with functions that have restricted domains. So how do we find the range? So we have three questions here. F of x is equals to minus 3x squared, where the x is restricted between minus 1 and 3. And the second question is the absolute value of x plus 5 minus 2. We have a restricted domain minus 8 to 0. But in the third problem, you see that the domain is not given. So we need to find the domain first. All right, let's start with number one. So for this one, we're going to apply two methods to solve this. Now, let's say the first method, you can call it analytic method if you want, or algebraic method. So what I will do here, we will use the fact that we have an even power. So if you have an even power, we know that x squared, since it's even, it doesn't matter what is x, where is x, x is coming from. This is always greater or equals to 0. Okay. So if x is 0, we know we'll have 0. Then let's use this information to try to create this function here. So it means that if I multiply this by 3, so we have 3x squared. This will be less than equals to 0 because we're multiplying by what? By a negative number, negative 3. But if you look at this, what have we done? We have created our function, which is f of x. So it means that f of x is less equals to 0. But what is f of x? F of x is y. So you say y is less than equals to 0. Now, what is the meaning of y less than equals to 0? This is what it means. It means that you have minus infinity to 0 close, right? But here, you cannot have minus infinity because if you have minus infinity, it means the domain is no longer restricted. The range is no longer restricted. But if you have a restricted domain, you should also have a restricted range. So now we need to find this 0 you are seeing is the maximum value of y. So we need to find what will be the minimum value of of y when we take x from this restricted domain. So let's do this. The restricted domain is this one, minus 1 close to where? To 3 open, right? So usually what we do in this case is that this is our f of x. Remember, f of x is minus 3x squared. So let's try the endpoint first, which is f of minus 1. If you try f of minus 1, put minus 1 here, you'll have this. And this will be minus 3 times 1, which is minus 3. So we can also try f of 3. And f of 3 will be minus 3. And this will be 3 square. So this is minus 3 times 9, which is minus 27. Don't forget, we are looking for what? We are looking for the smallest number. Now, in between minus 1 and 3, you can take as many numbers as you want, but I recommend anytime you have 0 in between the two interval, always try it. So let's try what is f of 0. F of 0 in this case will be what? Will be 0. So this is not what we need because we already have 0. 0 is already, we know, is the maximum value of y. So we can try as many numbers. For example, this is 0. You can decide to try one number here, as many as you want. So let's try again. Let's say I try f of 1, which is between 0 and 3. If you try f of 1, you're still going to get what? Minus 3, 1 square. This is going to be also minus 3. So now, if you look at all of these numbers here, f of minus 1, which one is the smallest? The smallest number here is what? Is minus 27. So now it means we can remove this what? This minus infinity. We cannot get up to minus infinity. And put what? Minus what? 27. Now, are we going to close it or open it? Remember, we obtained this minus 27 when x is equals to what? 3, right? But if you go to the domain, you can see that x equals to 3 is what? Is open. So it means the corresponding value of y should also be what? Should also be open. So here we will have an open interval from minus 27 to 0. All right. So this is the first method. Now, as of how many values do you choose? This is what I recommend. Take the first, the endpoint, right? Which is minus 1 and 3. Then, if there is a 0 between the interval, always try for 0 and maybe take 1 or 2 points. It's okay. You will get uh, what you want from there. Now, let's go for the second method. This one I call it, let me call it algebraic or something. Yeah, it's fine. Here, let's say graphically. Or here, let's say graphical method here. Let's graph this function. We know this function. What is the function? Let's start with x squared, right? Let's just start with what? With x squared. We know that this is the graph of what? Of x squared, right? This is the graph of x squared. Now you have a minus here. So this is like what? You reflect it across the what? The x-axis, right? Or you can decide to what? You can decide to multiply it by what? By 3 first. If you multiply it by 3, this is just like you're what? You're stretching it, right? So let's say something like this. So let's say this is your what? 3x squared. And now it's a stretch because you can see your c, your constant multiplying it is what? Is positive. So you can see this as a vertical stretching or a horizontal shrinking. Now, let's see. We can what? Reflect it now. We will have this, something like this. So this is actually the graph because we have reflected across the what? The x-axis. Okay, but what is our interest? Don't forget, our interest is on where? Between what? Minus 1 close and what? And 3 open, right? So it means we need to get what is the value of y, right? What is going to be the value of y when you have what? Minus 1. Let's say this is minus 1. And so what does that mean? It means you need to go and take what is the value of y on where? On the graph. So let's say you come down here and let's say you touch the graph at this point, yes? At minus 1. So you need to know what will be the value. But if you look at it, minus 1 is close. So since minus 1 is close, it means here you're going to have what? You're going to have a close point on the value of y. And what is that point? To get the value of that y, you just need to what? Substitute y minus 1 into what? The function. Don't forget that this function now, it's what? It's minus 3x squared. So if you substitute minus 1, what are we going to get? We're going to get, put minus 1 here, which we already have. This will be something like minus what? Minus 3. The same way, we have to get this one. This is 3. If you substitute 3 into the equation here, the function, you'll get what? You'll get minus 27. So this one will extend a little bit further. Let me just do it this way, right? And now it means this one should touch the curve at where? At minus 27, but it's going to be open. Why? Because x equals to 3 is open. So if I stretch this down a little, we're assuming that here is actually going to be minus what? 27. So this is what is the graph of this function. And as you can see from here, what will be the range is going to be the smallest value of y, which is minus what? 27. Then up to what? The maximum value of y is not minus 3, but the maximum value of y is going to stop here, which is at where? 0. But we have to close it because it's closed from the graph. So here also, this is our range here, and also here, this is our range. All right. So let's move to number 2. Now, for number 2, we're dealing with an absolute value function, right? So let's also use two methods. So what is the first method? Is to try to use what we know about an absolute value. We know an absolute value of x is always greater or equals to what? 0. This is always true for absolute value. And so what we can do is, we know this. So this also means that what? If you even if you add 5 there, it's still going to be greater or equals to what? 0. So because there is an absolute value, so you can even begin from here, it's fine. Absolute value of x plus 5 is always non-negative. So we can use this just like we did in the first example. Let's use this to construct this function. So we can subtract 2 from both sides. So this will be minus 2. If you subtract 2 from here, this will be what? Minus 2. So this is our what function, which is what? F of x. So f of x in this case is what? Is greater or equals to what? Minus 2. It means that y is greater or equals to what? Minus 2. So what the range should be, it means that the range, it's supposed to be what? The range is supposed to be from where? Minus 2. You can see this is what it means, greater than minus 2. But can we get to infinity? No. Why? Because our domain is restricted. So now we need to come and find what is the maximum value? What is the maximum value of this function in this given domain? So similar to what we did the other time, let's look at this one. Here, we are dealing with what? Minus 8, right? And here we have 0, but 0 we know it's open. So just like I said before, always try the what? The endpoints first. So this is f of minus 8 will be what? Absolute value of minus 8 plus what? Plus 5 minus 2, right? And what is that? This is minus 8 plus 5. This is minus 3. Absolute value of minus 3 is what? So you have absolute value of minus 3 minus 2. This will be 3 minus 2, which is equals to 1. Okay. Now, what next? We'll try to look forwards. Let's look for the value at where? At 0. F of 0 is what? Is absolute value of 0 plus what? Plus a 5 minus 2. This is going to be absolute value of a 5 minus 2. And this is 5 minus 2, which is what? Which is 3. Okay, so we see now we have 3, which is bigger than 1. Don't forget, here we are trying to get a maximum value. So based on using the endpoint only, we can see that the maximum value is what? Is 3. But let's try other points still within this interval. Can we get anything better? So let's try a number here. Let's say, for example, we try f of what? Minus 5. If we try minus 5, what do we get? You will get, this will be minus 5 plus 5 minus 2. This will just be what? 0 minus 2, which is going to be minus 2. Now, minus 2 is the minimum value, which is already here, so we don't need it, right? We are looking for the maximum. Try another one. Let's say, try something even more closer. Let's say minus 1. This will be what? Minus 1 plus what? Plus 5 minus 2. This will be, this is 5. So this will give us what? 4 minus 2, right? Yes, 4 minus 2, which is equals to what? 2. So you can see that these numbers, we don't have any number greater than what? Than 3. So in this case, the maximum is achieved at the what? At the end point. So it means we can remove this infinity and put what is the maximum value here, which is 3. So in this case, we achieve it at where? We achieve it at the what? At one of the endpoints. And just like we did before, this endpoint 3 is going to be open. Why is it open? Because we achieve this point at 0, and 0 in the domain is open. Okay, so let's go to the graphical method. So this is my method 1, and this method 2, right? For method number 2 is to what? Is to graph this function. Now, to graph this function is this. We can start with what we know. We know this is what? Absolute value of x should be something like a v, right? But with plus 5, it means it is shifted to the what? To the left. How many units? Let's say 5 units to the left. So we're supposed to have something like this, right? Let's say something like this. But it is shifted now what? Downward. How many units? 2 units. So if this is 0, so we'll be somewhere here at where? At minus 2. So this is where it's going to take off from. So we will have this one. Let's say this. And this way, some way. Okay. Now, as you can see, likely if you continue this, you're going to have a what? We're going to have a vertical intercept somewhere. We're going to have a vertical, not vertical, sorry, I mean y-intercept. So it's good for us to know what are these intercepts so that we know exactly which points to put there. Here you can see from the graph, we're going to have how many intercepts? 2 intercepts. So what is x-intercept? Let's look for the x-intercept first. X-intercept means y is equals to what? 0. So if you put y equals to 0 into the function, you will get 0 is equals to what? Absolute value of x plus 5 minus 2. And this means that what? If you transfer 2 to this side, this is just going to give you that x plus 5 is equals to what? 2. And now this is an absolute value equation which we can solve. Remember, anytime you have absolute value of x equals to b, and this b is greater than 0, it means that x equals to b or x is equals to minus b. So we'll use the same here. So see all of this as your x. So it means that x plus 5 equals to 2 or x plus 5 equals to minus 2. So let's remove this from here. Okay. So what does this mean? This means that x is equals to minus a 3, right? And x is equals to what? X is equals to what? This is minus 2, so this will be minus 7. So it means here, one of this here will be minus 3, right? And one of these will be what? Minus 7. So these are the x-intercepts. Now, the y-intercept, what is y-intercept? If I can do that here. What is y-intercept? It simply means that x is equals to what? 0. Put x equals to 0 in your function, you will get f of 0 is, I think we already have it. We have it here already. F of 0, we said, is going to be 0 plus 5 minus 2, which is going to be 3, right? Yes. I think we already have it here. Is the same thing as this one. So it's 3. So it means that what if this, remember this is x equals to 0. So it means the y-intercept here is at where? So this is going to be at 3. All right. Now this is just drawing the graph of what? This here. But we need to what? Restrict the domain. Now, in drawing this graph, I've not considered the domain. So now I want to consider the domain here. The domain is from minus what? Minus 8. So this is going to be, if this is minus 7, let's have minus 8 here. So if I have minus 8 here, then the value, I need to know what is the value at minus 8. Yes. So this is where I will stop. It means I have to remove these other parts because these other parts are what? Less than minus 8. So this is it. And you can see that minus 8 is going to be closed. Why? Because it is closed in the domain. Now, what is the corresponding value of y, of f of minus 8? Here, earlier, you can see when we're using this method, we already found what is f of minus 8. And f of minus 8 is what? Is 1. So it means that this point here, the value of y here is going to be 1. Okay? Then, what is the okay, this is minus 8, right? But now we are considering what? 0 open. So 0 open, this is 0. And at 0, we have the what? The y-intercept here, which is 3. But because 0 is open, it means I have to come here and open this 3. So this is, so if you look at this graph now, it's restricted between what? Just minus 8 and what? And x equals to 0. That is why it does not cross. Remember, absolute value is supposed to continue like this, right? But it cannot continue. You have to remove all these parts and just stop at 0, and you open it at where? At 0. You open it at 3 because 0 is what? Is open. So I think we have all that we need. This is the complete graph. So from the graph, we can see that what? The range, which will be the smallest value of y, remember here is closed, right? Is what? Is minus 2. Then the maximum value It's not this one. If you stop here, you're going to get 1. So it has to be this one where you have the y-intercept. So it will be 3, but that 3 will be open. So, okay, this is it. Um, let's see. All right, I think it's good. Let's go to question number 3. For question number 3, you have f of x is equals to what? The root of 4 minus what? Minus x squared plus what? Plus 1. Now, in this question, we don't even know the domain. So the first thing is we find the domain. What is the domain? How do you find the domain? Don't worry about the 1. The domain, just take, you have an even root. This even root, whatever is inside the even root cannot be negative, right? Because if it's negative, you're taking the square root of a negative number, which becomes an imaginary number. So it means you just want it to be what? Either it is positive or it is what? 0. So we solve for x. This means that what? This, you can take x squared to the other side. So you have this. And I can rewrite this. I like rewriting it like this. Yes. So you take the square root, and this is the square root of 4. This will be absolute value of x is less than equals to 2, right? Okay. Now, why do we use absolute value? Because we have even roots and what? Even power. So here, what is the meaning of this? Remember, if you have absolute value is less than what? A c. This means that minus c is less than x is less than equals to c. So it means that we have minus 2 is less than equals to x is less than equals to 2. So this becomes the domain. So the domain in this case is what? Minus 2 close to where? Minus to 2 close. So we can see the domain is what? It's restricted. And this will affect what the range will be. Now, let's go to solve the range. We will still try to use two methods for solving the range. So let's say method 1. Method 1 is, what do we do? Use the fact that what? Anytime you have an even root is always what? Non-negative. Yeah, so get the difference. Here you are not taking the contents of the root. You are taking everything, including the roots. This is always true for even roots. Then we can use this to construct what we have. So we can add 1 to both sides. Is that okay? Now, what will this be? This is nothing but your function, f of what? Of x, which is greater or equals to what? 1. And what is the meaning of that? This means that y is greater or equals to what? 1. And which implies that we have what? 1 to 1 to infinity. Yes? Okay. Now, the question is, can we get to infinity? No, because the domain is restricted. So what do? We need to find what will be the what? What will be the largest value now? So similarly to what we've been doing, this is minus 2, but in this case, both of them are close to 2. What is our function? Again, let's remind ourselves, our function is 4 minus x squared plus a 1. Is that okay? Now, look at this now. You can try to test the values. So I can test f of what? Minus 2. F of minus 2, you will have So minus 2 squared plus 1. And this will be what? This will be square root of 4 minus 4 plus 1. This is just going to be 1 because this will be square root of 0. Now, let's try the other endpoint, which is f of 2. F of 2 will be 4 minus 2 squared also plus 1 is also 4 minus 4 plus 1, which is 1. Then, between the interval minus 2 and 2, you can see there is a 0. So I said always try the 0 if you have a 0 in the interval. So this will be 4 minus, it will be 4 minus 0 plus 1, right? And what will that be? This will be just the square root of 4, which is 2. So you have 2 plus 1, which is what? Which is 3. Okay. Now, we can try, remember we just tried 0. You can try other numbers. For example, in between here, let's take minus 1. Let's see. F of minus 1, you will have root of what? 4 minus 1 plus 1. So this is root 3 plus 1, right? But we know what is root 3. In approximate value, this is going to be approximately, this is approximately 1.7. Yeah, let's say this is going to be less than 2. So let's say 1.73. So this is approximately, let's say 2.7. Yes, just, yeah, 2.7 approximate value. Now, here, let's also try another one. Let's say you try f of 1. You see f of 1, because of the square, is still going to be the same. So this is still going to be root 3 plus what? 1. This is equals to what? Still 2.7, right? So here you can see that the maximum value is achieved where? Is achieved at 0. And what is that value? That value is what? Is 3. So we can come here, remove the infinity, and put what? 3. But now, this 3, is it open or closed? It is closed. Why? Because we achieved it at 0, yes? And you can see 0 is within this interval. 0 is closed in this interval. So it means the 3 also needs to be closed. All right. Now, let's go to the second method, which is method 2. When I say method 2, I mean the graphical method. We try to graph this function. F of x is equals to what? Plus 1. Now, to graph this, you can take values of x, then try to get the corresponding value of y and plot it. So let's do that. But you have to restrict yourself. You can use transformation, but here, let me use this one. Let's use this one in this case. So take some values of x and take some value of y. When I say value of y, I mean the value of f of x. But the x you are going to consider now, you are to consider the x's between what? The x's that you have must be which of the x's? Can you consider the x in the domain, right? Yes. What is the domain? From minus 2 to 2. So we can start from minus 2. We can take minus 1. We can take 0. We can take 1. And we can take what? 2. Because this is our restricted domain. So we can do this. And to get the value of y is not difficult because we already have some values here from this one. So what is y when it is minus 2? F of minus 2, as you can see, is what? Is 1. So we have this. f of minus 1, I think we calculated it here, is what? 2 points, approximately 2.7. Then f of 0 is what? Is 3. f of 1, f of 1 is what? F of 1 is also approximately 2.7, so let's keep it this way. And f of 2 also happens to be 1, so this is it. Now we have an idea of what you should plot. So remember, our domain is very important. Minus 2 to where? To 2. You can't do anything outside this domain. So at minus 2, we are where? We are 1. So at minus 2, we'll be somewhere here. So it means that this is 1. Then at 2 point what? At minus 1, we are 2.7. So if this is minus 1, 2.7 is definitely greater than 2. So let's put it here. So it means that here is what? 2.7, approximately 2.7. Now, at 0, we are where? 3. So remember, this is 0. So 3 will be, 3 is greater than what? 2.7. So let's say here. So this is 3. Then when we start coming, look at 1 again. Remember, 1 is here. At 1, the answer is what? 2 point, y is 2.7 again. So it means it's going to be still on this line, 2.7. Then at 2, you back to what? To 1. So we're here. Now, if you look at this point, you can definitely, this is like a curve, right? And something like this. Okay? So this is something like this one. And from here, we can take what is the range. So from the range here is what? Remember, here is closed. They are all closed at both ends. Both at minus 2 and 2, they are closed. So the value of y is also closed. And what is that value of y? It's 1. And what is the maximum value? The maximum value is here. Here is also closed. So this is what? 3. So we have this range. All right. So I hope this is video is clear. So this is how to find the domain, the range, when you have a restricted domain. You can use this method 1, which is more of analytical method, or yeah. Then method 2, you can use the graphical method. I hope you enjoyed this video. Thanks for watching. Okay, please do not forget to like this video and share with your friends. And subscribe to my YouTube channel for more interesting videos on how to find range. The next video hopefully will be on how to find a range of piecewise defined function.